Hello, quick video on natural log and exponent questions in the C3 syllabus, and I'm going to use two questions here to illustrate what you're going to see. First one here from June 2006 starts with effectively with a log equation, and you've got to solve for that. And the second question in question 5 here from 2011, they start with an exponentials and you've got to solve from that. Both of them effectively take us into quadratics or solutions to them, and also you need to bear in mind what valid values there are for these functions. So yeah, can't have the log of a negative number in x, and e to the x is always greater than 0. So that's what's going to take us to a solution. Okay, so let's start by solving some of these. Firstly then, express log x plus log 3 as a single algorithm. Well, all our log laws work, don't they? So 2 log x plus the log of 3, all our log laws work, so therefore 2 log x is going to be log of x squared, because that's effectively x times x, isn't it, if we've got log x plus log x, and there's our log plus our log 3, and if we're adding 2 logs we're multiplying them, so that's the log of 3x squared. That was easy. Got a mark or 2 there, wasn't it? There we go. Yeah, 2 marks for that. Next is, given that x satisfies this equation, show that x is a root of this quadratic here. Okay, so let's just write the equation then. They've given us, this time they've got 2 log of x plus the log of 3 must equal the log of 5x plus 2. 5x plus 2. There we are. And we've just organised the left-hand side here into a single log in the first part. This is a journey question again, as ever. So on the left-hand side, we have the log of 3x squared equals on the right-hand side, the log of 5x plus 2. Now, if the log values are the same, then the values of the values inside the log functions must be the same. Therefore, 3x squared must equal 5x plus 2. Yeah, and it doesn't take as much to see here that that's a quadratic with 3x squared minus 5x minus 2 equals 0. So there's our quadratic. So that was our next set of marks. Got 2 marks for doing that. Third part, solve this quadratic, explaining why there's only one root is valid, a valid solution to this. Okay, so let's solve it and then explain why we've only got one valid root. So solving number 3 here. So if we quickly look at that, 3x squared minus 5x minus 2, starting to see something that looks like it might have a factor. That's probably the quickest way into this one, isn't it? Because we might see one along the way. If we went through that and factoring, we'd probably see that there's a factor here of x equals 2. Let's just have a quick look at that. Yeah, isn't it? Because the first one's going to be 12, take away 10, take away 2. So if you're happy, you can see here that we've got a factor is x minus 2. If you're not so happy with that method, we could do factorization. Have a quick look at factorization. 5x there equals 0. If we're using the factor method, then we've got to multiply those 2 numbers together. And we'd say that the multiple of our 2 numbers must equal minus 6, and that the sum of our 2 numbers must equal minus 5. So if we started off with 1 and minus 6 as our 2 values, A and B, then AB is minus is the minus 6 we're looking for, and if we add them together we end up with minus 5. So that's the right one, isn't it? We could have gone minus 1 plus 6, in which case we'd got plus 5 for our sum. So we don't need that. So we know that one of these brackets is going to be, therefore, one of our values is plus 1 and the other value is minus 6. And as we've got a 3 out the front, slide, divide, multiply, if you've watched that lovely video. So I'm going to divide both of those by minus 3. This one, the right hand factor here, that's going to cancel out, so this right hand one's going to become x minus 2, isn't it? And the left hand one doesn't cancel at all, and I don't like having a fraction, so I'm going to multiply it out and I end up with 3x plus 1. Yeah, are we happy that we've got our factors through that method? Okay, and therefore our solutions to this will be minus 3 and plus 2. Okay, so that's our solutions to our quadratic. Marks that. So why is it that only one of these is valid? Well, our original equation was in terms of the log of x, wasn't it? And log of minus 1/3 does not exist. Yeah, because our curve for a log goes like that. It's never in the 3 and 4 quadrants. The second equation here would be log of 2, so that's okay, isn't it? So we've only got one root. Our one root is x equals 2, and if x equals 2, so therefore x is 2 is the only valid solution. Okay. See there that we used the properties of the log. Okay, let's do question number 2 now, shall we? On a single set of axes, sketch these two functions, and then it says find the exact coordinates of the point of intersection of the curves, yeah? Okay, so let's go down and do a bit of sketching quickly. This is question 5, isn't it? Here we go. So the first one, I'm going to do this in colours to help us. I'm going to put the axes here first. Ready to go. Okay, so the first one was y equals e to the x minus 1. Well, that's our e to the x function, isn't it? Minus 1. So our normal e to the x would come down to the x-axis. So in this case, it's going to come down to the minus 1. And when x equals 0, we know e to the 0 is 1. E to the 0, 1 minus 1 is 0. So we're looking at a curve. Oops. So we're looking at a curve that comes down and through the origin. Yeah. So that's that one dealt with. Now let's have a quick look at our second curve, which is y equals 2 times e to the minus x. Well, I've got a minus x, so the curve's going up to the left and down to the right. And when x equals 0, e to the 0 is 1. 2 times 1 is 2. So it goes through the axis at 2. And it's coming up like that. There we go, exponentially with the gradient always increasing. So that's our graphs for those 2 points, and then it's asking us to find the intersection exactly. So we can't do it graphically, we're going to do it exactly. So we're going to equate these two functions. So e to the x minus 1 must equal 2e to the minus x. Now, using our knowledge that e to the x e to the minus x is 1 over, we want to get this into a function of, so an equation in e to the x. So if we multiply through the whole equation by that, we end up with e to the x all squared minus e to the x equals 2. And if I just, to make it even clearer, substitute in z equals e to the x, what we've got here is z squared minus z equals 2, and therefore z squared minus z minus 2 equals 0. Again, quickly looking at this in factorization, we can see that z equals a minus 1 would set this to 0, wouldn't it? So therefore we've got a factor of z plus 1, and using factor theorem, and therefore the other bracket must be z minus 2, mustn't it? Therefore the solutions to this are minus 1 and 2 for z. But of course z is actually e to the x, so popping down a sec, that means e to the x equals minus 1 and 2. And what do we know from our curve what we were looking at earlier? Here's a curve, and here's a curve of e to the x. It goes like that, going through the point 1, doesn't it? It never goes negative here. It's not, never has a it never goes below the x-axis. So we can't have a solution with e to the x equals minus 1. Therefore, we know that our only solution is e to the x equals 2. Therefore, x equals log of 2. And once we know that, we can substitute that back in, sub back, can't we, into our equation. And we know either equation we could use, but I'm going to use the y equals e to the x minus 1, because I know that e to the x is 2. We've just found out 2 to minus 1 is 1. So what have we got? Our solution for this intersection point is log 2, 1. There we go. That's the point that we wanted to find. Went back up and had a quick look at our graph. There it is up there. That'd be log 2, 1. There we go. Okay, finally a quick summary of our learning points. I think there's only 3 main ones here. Well, all our laws still operate, our log laws, even though we're natural logs. Therefore, log A plus a log B must be the natural log of AB. And n times the product of n and log of A will be the natural log of A to the n. 2 other points then for solving these type of questions and equations is that the log of x only exists if x is greater than 0. Therefore we can eliminate solutions with negative values of x. And secondly, e to the x only has positive values. It doesn't exist below the x-axis. As of course, because these 2 functions are inverses, as you can see in the little diagrams, and we can use them like that. And quite often in these questions we're ending up with a quadratic, so not too difficult at all, as long as we keep our mind on it. Hope that's of use. Bye.